This is our CT review for day 8. We're given the following graph and asked to label the various features of it. First, we're asked for the vertex. The vertex is down here at 2, -9. Our direction of opening, well, we've got the standard happy face here, so the direction is up. Our zeros, or x-intercepts, are -1 and 5. Our y-intercept is here at -5. And our axis of symmetry, right down through the middle, halfway between our zeros, is 2. Determine the first and second differences using the data in the table. Does the data represent a quadratic relation? Well, the first differences are different, so it's not a linear relation. The second differences are the same, so it is indeed a quadratic relation. Question 3, a ball is kicked into the air and its path is shown in the graph at right. State the vertex. The vertex is right here. Explain what the vertex represents. Well, the vertex is the time, 10 seconds, at which the ball is at its maximum height. State the zeros. Here are the zeros here. And the zeros represent the height and the time at which the ball is kicked. Here the ball is at 0 meters at 0 seconds. And then the ball is at 0 meters again 20 seconds later. State the y-intercept. That's 0. And explain what the y-intercept represents. Well, the y-intercept here represents 0 seconds, the time at which the ball is kicked, and the height at which the ball is kicked from. Complete the table of values and graph the equation y = x squared plus 2x minus 1. Use values from -3 to 1. Well, here's our equation, x squared plus 2x minus 1. Here's the x values that we'll be plugging in. We plug in -3. We end up with coordinates -3, 2. We'll complete the rest of the table, substituting the given x value and coming up with a corresponding y value. We plot these points, and this is what they look like on the graph. For the relation represented by the equation y = -2x squared plus 3x, explain how you can determine which direction the graph will open. Well, the coefficient of the x squared term is negative, so this tells us that the graph will open downwards. Question 6, graph y = x squared minus 2x minus 8 by finding key values. Well, we'll start by factoring the equation, and when we factor them, it'll give us the zeros. So x minus 4, x plus 2 is the factored form of y = x squared minus 2x. If the factored form is -4 and +2, then the zeros will be +4 and -2. The axis of symmetry will simply be the x-intercepts added together divided by 2, so that'll give us 1. The vertex we can get by taking the x value, plugging it back into the equation, and that will give us the y value. So our y value of the vertex is -9. So the vertex is 1, -9. So here's all of these bits of information all in one table. And when we graph it, it would look like this. Expand and simplify the following expressions. Hint, use FOIL. Well, x plus 2 times x plus 3 gives us the following. We'll collect the like terms for an answer of x squared plus 5x plus 6. Doing the same thing for question B, we'll simply use FOIL, collect our x terms for a final answer of x squared minus x minus 12. Here we're using difference of squares. So this is a perfect square, this is a perfect square, separated by a negative sign. The square root of x squared is x. The square root of 16 is 4. So our factored form is x plus 4, x minus 4. Over here in question B, the square root of x squared is x. The square root of 49 is 7. So our factored form will be x plus 7, x minus 7. Product sum method. We're looking for a pair of numbers that add up to -4 and multiply together to be -45. And those pair of numbers just happen to be -9 and +5. For this trinomial, we're looking for a pair of numbers which add up to -10 and multiply together to be 16. And that pair of numbers is -2 and -8. For question E, we're looking for a pair of numbers that add up to 11 and multiply together to be 24. And those two numbers are 3 and 8. Here, we're asked to do some common factoring. So what is a number that can divide both into 3x and 24? That happens to be 3, leaving us with 3 bracket x minus 8. Question G is a little bit more complex. The numbers have a common denominator of 4, but if you'll see, each term has an x value. So we have to take that into account as well. So 4 will be our numeric common factor, but x squared will be our lowest variable factor as well. So we'll have to use 4x squared. Let me back up for just a second. The first thing I'm going to do is I'm going to rewrite this in order of descending exponents. So this is x to the 4th, x squared, and x cubed. I'll just rewrite this. X to the 4th is the largest exponent, x to the 3rd is the second largest, and x squared is the smallest exponent. So as stated before, 4 will be the greatest common numeric factor, but x squared is our greatest common variable. So 4x squared will be our greatest common factor, leaving us with 4x squared bracket x squared plus 8x minus 4.